Okay. So first of all, what are complex numbers? Now, if you remember that there are some situations where we get a math error. Okay, one is that if you do 1 divided by 0 where it's infinity. Okay, now that is an error because that is impossible for the calculator to compute. Okay, therefore you get a math error. There are other situations as well where you get a math error, and that is when you are trying to work out imaginary numbers. Okay, so what you can do for that is you can actually change the mode of your calculator and figure it out. Okay, but you can never figure out tan 1 divided by 0 irrespective of the mode that you're in. But let's say square root of -9, you can figure that out. Okay, so what are complex numbers? Complex numbers are basically imaginary numbers. Okay, numbers that we don't see on the number line. So they are imaginary numbers. That is numbers not seen on the number line. For example, if you try and take out the square root of -9, okay? So let's see what the square root of -9 is actually equal to. So under normal circumstances, under the regular mode of your calculator, you can't work out square root of -9. Let's try it out, okay? So let's go back to the normal mode. Square root of -9, oh, sorry, square root of -9, not +9. You get a math error, okay? But if you do this one thing where you go to menu, okay, and you change the mode of your calculator to complex, okay, you can see this I here. This I stands for iota, or you can say it's for imaginary. We're going to talk about what that is. Now, if you try and work out square root of -9, it is possible, okay? So square root of -9 is an example of an imaginary number, or any other square root of a negative number, or square root of -4, okay? So we saw that how the square root of -9 is actually equal to 3 iota. So in complex numbers, the square root of -9 is actually equal to 3 iota. The question is how? The answer to that is by making a small assumption, okay, and setting I, which is basically referred to as iota, equal to the square root of -1. Okay, so what's I equal to? I is equals to the square root of -1, and which is why root 19 is equals to 3 iota. And what's the reason behind that? The reason is this. That's root -9 is equals to 3 iota because of this. That root -9 can actually be written as square root of 9 times the square root of -1. Okay, which means that this becomes 3 into iota, and therefore it's equal to 3 iota. Okay, so that's the reason. Now, the way that we write complex numbers is that sometimes it's a mixture of, like you might have seen if you solve a quadratic equation, you might see that if you solve a quadratic equation which has no real roots. Okay, let's solve a quadratic equation which has no real roots so that you can understand what I'm talking about. So here we're solving an equation, a second degree polynomial. Let's say it's 1 square plus 4x plus 1. So if you solve this, so wait, this is possible. B squared minus 4ac. So let's make this 5. Okay, now what do you see? You see -2 plus iota. Okay, and then you see -2 minus iota. So this entire number is an imaginary number, although it has a real part, but it has an imaginary part as well. So together, collectively, this is an imaginary number. Okay, and the symbol that we use is the symbol z. Okay, z is what we use to represent a complex number. And the standard form, you know how there's a standard form for the equation of a straight line, standard form for the equation of a quadratic curve, cubic curve. So there is a standard form for z, and that is a plus b iota. Okay, so this is the standard form, or you can say the general form of a complex number. Okay, now A, as you can see, is the real component. Okay, A, as you can see, is the real component. You know how you have an X and Y component? B, as you can see, is the imaginary component. Okay, so if the way that we write it is this, that the real component of Z is equal to A. This means that the real component of Z is equals to A, and the imaginary component of Z is equal to B. Okay, don't take this lightly. These are the symbols that you will notice are used in exam, okay, or in past papers. So let's say that you're given, Z is equals to 5 minus 3 iota. Okay, and along with that, you are given that W is equals to 6 plus 4 iota. Okay, just random numbers. Now here, the real component of Z is equal to 5, and the imaginary component of Z is equal to minus 3. And just like that here, just like how you have functions which you can express using f, g, h, imaginary numbers can also be expressed using z, w. Mostly you will notice that it's z and w. So the real component of w is equals to 6, and the imaginary component or the imaginary part of w is equal to 4. Okay, no need to write 4 iota because here we're already mentioning that it's the imaginary part. Okay. Now, sometimes it's possible, let's say this is Z1, let's call it W1. So Z1, Z1, W1, W1. So let's say we have Z2, which is equal to simply 5 iota. Okay, and let's say we have W2, which is equal to 7. Okay, so what that means is that Z2 only has an imaginary part. So that means this is not a mixture of real and imaginary. This is purely or entirely an imaginary number. Okay, this is purely an imaginary number. And this is purely a real number. Okay, so this is no more an imaginary number. This is purely a real number. And why is that? Reason is very simple. The reason why this is an imaginary number is because there is no real element to it. The real element of Z2 is 0. Okay, and you only have an imaginary element. And the reason why this is a purely real number is because there is no imaginary element to it. Why? Because it's equal to 0. Okay, so pretty simple so far. A significant portion of this chapter is fairly simple. Okay. Now let's talk about just like how, you know, if so you notice that this chapter has a lot of similarities with multiple chapters, and one is rationalization. Okay, that is surds basically. So the same rule that we apply to addition and subtraction of surds, we apply to addition, subtraction, multiplication, and division. We apply to complex numbers as well. So addition, subtraction of complex numbers. And the rule to remember with this is the same rule as I like to use with surds, and that is apples with apples, or you can say apples to apples and oranges to oranges. Okay, that's just a simple trick. इसका मतलब है कि आपने apples to apples comparison करना है and oranges to oranges comparison करना है. Meaning is very simple. So let's say that you have a question. So this is question number 1. Just some random numbers. Okay, let's say you have Z, which is equal to 3 minus 4 iota. Okay, and W 7 plus 2 iota. Okay, so if let's say that in this part you want to do Z plus W, so first let's write it down. That means 3 minus 4 iota plus 7 plus 2 iota. So 3 plus 7, remember apples to apples, 3 plus 7 is equals to 10, and oranges to oranges. 4 iota will be added, minus 4 iota and 2 iota will be added together. So that's equal to minus 2 iota. Okay, that's your answer. Let's say in part B, you're supposed to subtract. You're supposed to do Z minus W. So the same rule applies that you do 3 minus 4 iota minus With subtraction, it's always a good idea to make a bracket. 7 plus 2 iota. So we have 3 minus 4 iota minus 7 minus 2 iota. So 3 minus 7 is minus 4. Minus 4 minus 2 is minus 6 iota. Okay, there we go. That's the answer to part B. Okay, if you guys have any questions so far, please do let me know. Addition subtraction is a fairly easy concept. We're not going to spend a lot of time here. We are, however, going to spend time when it comes to multiplication and division. So let's talk about multiplication. Now, before I talk about multiplication of complex numbers, there is an important concept which you guys need to understand. Okay, you guys need to ideally memorize. Okay, first understand and then you can memorize. So we know that square root of iota, we know that iota is equals to square root of minus 1. What happens if I take the square on both sides? That means we'll square both sides. Okay, and I becomes I square. And what happens if I take the square of the square root of minus 1? The square root and the square cancel out each other, and iota square is equals to minus 1. Then if I find out I cube, that means minus 1 multiplied by square root of minus 1, which basically means that I cube is equals to minus 1 iota or simply minus iota. Okay, that's what I cube is. Then I4 means that I squared into I squared, which means minus 1 into minus 1, which means I power 4 is equal to 1. Okay, so the standard rule is, the standard pattern is that iota is equals to square root of minus 1. Okay, iota squared is equal to minus 1, and iota cubed is equal to minus iota, okay, or minus the square root of minus 1, up to you how you want to write it, minus the square root of minus 1, and I power 4 is equal to positive 1. Okay, so this pattern continues. Standard and with the help of this, we can figure out pretty much anything there is. Yeah, so basically with the help of this, if let's say you want to find out I raised to the power of 9, okay, let's say that's what you want to do. So how can you do this? You can do this like this. I power 8 into iota. Now what's I power 8 going to be? I power 8 is going to be I power 4 squared into iota. So I power 4 we saw is 1. 1 squared into iota. That means iota is equals to what? Iota is equals to square root of minus 1. So the final answer is simply iota or the square root of minus 1. Okay, so with the help of this, yes, I power 5 is equals to iota. With the help of this, you can figure out pretty much anything there is. You can even do this. You know, you have questions like these in SAT. You can even, with the help of this, figure out something like I power 200. You know how? Here's how. You can rewrite this as I power 4 into 50. Now, what's I power 4 equal to? That's equal to 1. So 1 power 50. Now, it doesn't matter what I raise 1 to the power of. The answer is always going to be 1. Okay, so you can use this. You can use these 4 powers and figure out pretty much anything, any other power that it is that you have to figure out. Okay, so keeping this in mind, let's deal with multiplication of complex numbers, and you'll see why this is important. So let's say that you have, once again, you have z, which is equal to 3 plus 2 iota, and w, which is equal to 4 minus 3 iota. Okay, now let's say this is, okay, so this is question number 2. Sorry, question number 1. Part. Yeah, let's say this is the first example of multiplication. Okay, and you have to find out ZW. Okay, so you're given Z and you're given W, and you have to find out ZW. Okay, so remember the rule is that we treat this the same way we treat multiplication of surds. okay, which you must remember from AS. So 3 plus 2 iota is being multiplied by 4 minus 3 iota. How do we do this? Here's how. 3 times 4, what's that equal to? That's equal to 12. Then 3 times minus 3 iota, that's equal to minus 9 iota. Then 2 iota times 4, what's that equal to? That's equal to 8 iota. Then 2 iota times minus 3 iota, which becomes minus 6 iota squared. Okay. So 12 minus 9 iota plus 8 iota, which I think we should simplify. Yes, we should definitely simplify. So that becomes minus iota. Now be careful over here. Minus 6 iota squared, as we saw, is equal to minus 1. So this becomes 12 minus iota plus 6. So the final answer is 18 minus iota. Okay. So whenever you're multiplying two complex numbers, remember when I and I multiply, the number turns into a real number. Okay. Let's do another example. Let's say that you have z to be equal to 4 minus 7 iota. Okay, and w is equals to 2 plus iota. Now, once again, let's find out zw. So here's what we're going to do. 4 minus 7 iota multiplied by 2 plus iota. Let's see what happens. 4 into 2, that's 8. 4 into iota, that's 4 iota. Minus 7 iota into 2, so that's minus 14 iota. Minus 7 iota into iota, so that's minus 7 iota squared. So we have 8 minus 10 iota minus 7 into minus 1. So this becomes positive 7. 7 plus 8 is 15. 15 minus 10 iota is the final answer. Okay. Now, if you have any questions, please feel free to ask. If not, then there are two more examples that we're going to solve. Okay, and with the help of these examples, we're going to learn a standard rule, which we're going to use later on. Okay, we're just going to write down the standard rule and we're going to use this later on. So let's say that we have to do the following. We have to do iota times 4 plus 5 iota. Okay, so the two numbers that we're multiplying, one is iota, the other is 4 plus 5 iota. Okay, now I want you guys to see the result of this. Okay, I want you guys to see the result of this. Now, when we do I times 4, we get 4 iota. Okay, and then if we do I times 5 iota, we get plus 5 iota squared, which means that we have 4 iota minus 5. So notice what happened. This becomes minus 5 plus 4 iota. So if you look at this number, okay, if you look at this number, the real number, the real component of this was, okay, well, let's say this is, yeah, in fact, let's ignore that. Let's say the real component, let's just write that down. Let's say the real component of this was 4 and the imaginary component was equal to 5. Okay, and then if you look at this number, after multiplying it by iota, notice what has happened. The real has become minus 5 and the imaginary component, okay, the imaginary component has become positive 4. Okay, so we can come up with inverted, exactly. We can come up with a standard rule over here. That is that if, let's say, the points, let's treat them as two coordinates. Okay, we will be treating them as two coordinates later on. So the two coordinates are 4, 5. Okay, now after I multiply them by iota, notice what happens. They become, this is what they become. They become minus 5, 4. Okay, so what's the standard rule? Here's the standard rule. The standard rule is that if you have iota and you multiply it by a plus b iota, then the result becomes minus b plus a iota. And this is no magic science. This is no rocket science. And this is no magic. The reason is that a iota times b iota becomes b into iota squared, which becomes b into minus 1. And that's the reason. So this is the standard rule. Okay, and then there's another standard rule. Okay, and what's that? The other standard rule is this, and I'm just going to write this down. No need to do an example question here. That if instead I multiply minus iota with a plus b iota, then what happens is this. This becomes b minus a iota. So these two are basically your standard rules. Now, any questions so far? If yes, feel free to ask. If not, then we're going to do something called conjugate. And with the help of that, we're going to do division as well. Okay, great. Now, once again, a similarity to surds. If you remember the concept of rationalization, we multiplied with its conjugate. So if let's say z is equals to a plus b iota, then the conjugate of z would be, we write a star to distinguish the conjugate. It's going to be a minus b iota. Okay, so the rule is that the sign of the imaginary component changes. Okay, so it's only the sign of the imaginary component that changes. Okay, changes. If it's positive, it becomes negative. If it's already negative, it becomes positive. Okay, don't make a standard rule that it will always become negative. It depends on what the sign already is. So let's say z is equals to 3 plus 2 iota. So z conjugate would be 3 minus 2 iota. Let's say w is equals to 1 minus iota. So the conjugate of w would be equal to 1 plus iota. Okay. And another important thing to observe is this. Notice what happens if I do z multiplied by its conjugate. Okay, notice what happens if I multiply the two. So if I multiply the two, technically what I'm doing is we end up in a situation where the third algebraic identity is applicable. We end up in a situation where it's similar to a plus b into a minus b. So that means we can solve it like the third algebraic identity, and that would be 3 squared minus 2 iota, minus 2 iota whole squared. So this becomes 3 squared minus 4 iota squared. Now 4 iota squared is what? 4 iota squared is basically minus 16. So this becomes 9 minus 16, which means 9 plus 16, which is equal to what? Which is equal to 25. Okay. And this becomes a standard rule as well. So before we call it a standard rule, let's see it in action one more time. So let's say we have 1 minus iota multiplied by 1 plus iota. So once again, we're going to do 1 squared minus iota squared. So we have 1 squared minus 1, which means it becomes 1 plus 1. And as you can see, this becomes 1 plus 1, which is equal to 2. Okay. So what's the standard rule? The standard rule is that z into z conjugate is equal to a plus b iota into a minus b iota, which eventually becomes a square plus b square. This is the standard rule. Okay. Sir, you wrote, what did I write? Oh yeah, I was not supposed to square it over here. I've already squared it. The square is only going to be 1 iota. Okay. Thank you for pointing that out. Okay, now with the help of this concept, we're going to do division of complex numbers. Okay, with the help of this concept, we're going to do division of complex numbers, and then we're going to do simultaneous equations. So let's say that you have the following. Shouldn't it be? Okay, it is a square minus b square, but then it becomes what? Then it eventually becomes a square plus b square. Why? Let's add an extra layer of working to see how that works. So it is a square minus b iota squared. Okay. And then it becomes a square. Okay, a square minus b squared and iota squared. Now what's iota squared? That's equal to -1. So that's why it eventually becomes a square plus b square. There you go. Okay. There you go. Now, division of complex numbers. Once again, an easy concept, okay, not too complicated. Let's say that you have, could be lengthy. Some questions can be extremely lengthy, but unless we get to organ diagrams. So you guys might have heard this, those of you who have already done P3 at school, or those of you who have done this chapter. Organ diagrams are the only part of complex numbers that are complicated, okay? The rest is a piece of cake. So let's say that you have z, which is equal to 3 plus 4 iota. Okay, and let's say that you have w, which is equal to 1 minus 2 iota. Okay, and what you're supposed to do is you're supposed to do z upon w. So this is example number 1 of division of complex numbers. So the way that we write it is this: 3 plus 4 iota divided by 1 minus 2 iota. Okay, and now what do we do? Well, keep the end result in mind, that the end result should be something like this: a plus b iota. Okay, this is what the end result should be. Okay, so this is what we are aiming for. And that's not how it is right now. Okay, right now we have a denominator which has an imaginary element to it. So that means we need to get rid of that. So how do we get rid of that? The same way we get rid of an irrational number from the denominator. We multiply the numerator and the denominator by the conjugate. Okay, we multiply the numerator and the denominator by the conjugate, which basically means that we multiply the numerator by 1 plus 2 iota, and we multiply the denominator by 1 plus 2 iota as well. Let's see what happens as we do that. 3 into 1 is 3. Okay. Then 3 into 2 iota is 6 iota. Then plus 4 iota. Then plus 8 iota squared. Now, as far as the numerator goes, things are always going to be done in one direction only. And that is, we'll have 1 squared plus 2 squared. Okay, a squared plus b squared, which is 1 squared plus 2 squared. So 8 iota squared will be minus 8. 3 minus 8 will be minus 5, plus 6 iota plus 4 iota, that's 10 iota, divided by 1 plus 4, which is equal to 5. Now, this is not how we leave it as. Instead, we leave it like this. We write it as minus 5 upon 5, because we can simplify it further. So we're going to do that, plus 10 iota upon 5, which basically means that we have minus 1 plus 2 iota. There you go. Minus 1 plus 2 iota. That's the final answer. Okay, let's do another example. Let's say that we have z equal to 2 plus 3 iota. Okay. And w is equals to minus 4 minus 5 iota. Okay, just two random numbers. And here also we're supposed to do z over w, which means 2 plus 3 iota divided by minus 4 minus 5 iota. So same rules, we multiply this by minus 4 plus 5 iota, and we multiply the denominator also by minus 4 plus 5 iota. Now let's get to work. So we have 2 into minus 4, which is equal to minus 8, and 2 into 5 iota, which is equal to 10 iota, and then 3 iota times minus 4, which is equal to minus 12 iota, then 3 iota into 5 iota, which is equal to 15 iota squared. And with practice, you can straight away write this as minus 15. And then in the denominator, it's going to be minus 4 squared plus 5 squared. Okay, a squared plus b squared. That doesn't mean that you guys forget what the identity is and you start rewriting it as a squared plus b squared. It is a squared minus b squared. Only in the case of complex numbers, for this reason, it becomes a square plus b square. Okay, the identity does not change, the identity remains the same. Now, -8 minus 15, that's minus 23. 10 minus 12 iota, that's minus 2 iota, divided by 16 plus 25. What's that equal to? 16 plus 25, that's equal to 39. No, wait, not 39. That's equal to, let's work it out. 16 plus 25, that's 11, 41. Okay, now we can simplify it and write it as, let's see what we can write it as, minus 23 upon 41, minus 2 upon 41, and then iota separately. Okay, so this is the final answer. Okay, now if you have any questions, please do let me know. Let's do some more practice questions. Let's do some questions from the book now. We've been solving some very basic questions so far. Let's increase the difficulty level a little and see what's what. And now we're going to look into simultaneous equations. Now, most of the concept that we do will revolve around the concepts that we have learned. Okay, so we're just going to look into the applications of the concepts that we have learned. So here are some questions that we are going to solve. Okay, I'm sorry, these are not simultaneous equations. Sorry. These are not simultaneous equations. Just a second. They turn into simultaneous equations. Just a second. Okay, you know what? Let's call them simultaneous equations only. Now, let's do the first part. Okay. Now, the way that we solve this, we solve it by comparison. Okay, what do we solve it as? So what do we solve it by? We solve it by something called comparison. Now, how do we compare? Here's how we compare. So if you look at the first part, I'm going to solve the first part. We have x plus 2y plus 3x minus y into iota. I've rearranged it slightly, is equals to 1 plus 10 iota. Okay, so what we're doing over here is we are comparing. Okay, and how are we comparing? We're comparing real with real and imaginary with imaginary. That's what we're doing. Okay, and that's how we're going to solve all the questions that are. So what's the real component on the left-hand side? That's x plus 2y. And what's the real component on the right-hand side? That's 1. So that's our first equation. Okay, what's the imaginary component on the left-hand side? That is 3x minus y, because it's being multiplied by iota. You can think of this, think of it this way, that this is the coefficient of iota. Okay, so in a way, we're comparing coefficients. And what's the coefficient of iota on the right-hand side? That's 10. So there you go. These are the two equations that we're going to solve simultaneously. And if we do that, and given that we do it correctly, the answer that we get, I'm just going to write down the final answer now, because we all know how to do that. We all know how to solve two equations simultaneously. X equals to 3 and y equals to -1. Okay, let me solve one more question. I'll do part B, because this was very easy. We didn't really have to do anything. In part B, however, we have to first figure a few things out. X plus y minus 4 plus 2x iota is equals to 5 minus y into iota. Okay, so here's what we're going to do. We're going to keep all the unknowns on one side, all the x and y's on one side, and everything else on the other side. Okay, so we have x plus y minus 4 plus 2x iota is equals to 5 iota minus iota times y. Okay, or y times iota, it's up to you how you want to write it. So remember, x and y on one side, everything else on the other. So x plus y plus 2x iota already. And then if I shift I times iota times y, this is what we have. So we've dealt with this. Okay, whatever we've dealt with, let's put a check mark. So we've dealt with this, we've dealt with this, we've dealt with this. Okay, on the right-hand side, I'm going to move everything else. So on the right-hand side, we have 4 plus 5 iota. Now we can compare. Okay, but before we compare, let's rearrange things on the left-hand side slightly. So we have x plus y, those two are the real components, 2x plus y, the imaginary components, which is equal to 4 plus 5 iota. Now, real with real, that means x plus y equals to 4. That's your equation number 1. Okay, and imaginary with imaginary, which means 2x plus y. So this with this is equals to 5. That's your equation number 2. And we solve them simultaneously. And what do we get? This is what we get. I'm just going to write down the final answer here also. We get x equals to 1 and y is equals to 3. Okay, so if you have any questions so far, please do let me know. We are going to do one more concept. Okay, and yeah, that would be it. But we're going to do some practice questions as well. So I have another question which I'd like us to solve. Here it is. Okay, so this is just a miscellaneous example. It's not related to anything. It's just a miscellaneous example. It says, show that z is equals to 1 upon 5 plus 2 root 6 upon 5 iota is a solution to the equation. So how do I show that this is a solution to the equation? How do you show that any value is a solution to an equation? You plug it back into the equation. Okay, so part A is going to be lengthy, but this is the only way to do it. So 5 into z squared. That means 1 plus 2 under root 6 iota upon 5, the whole thing squared, minus 2 into z, which means 1 plus 2 root 6 iota divided by 5 plus 5 is equal to 0. Okay, so this is what we're going to prove. Now, 5, as far as the denominator is concerned, that is a no-brainer. That becomes 25. Okay. In the numerator, we use the identity that's a square plus 2ab. So that means 2 into 1 into 2 root 6 iota plus b square, which means 2 squared, which is 4, root 6 squared, which is 6, and iota squared. So let's write it as iota squared for the minute. Minus, here, this is what happens. We have 2. Okay, so you can write it like this. Minus, or you can open up the bracket. That's entirely up to you. So minus 2. So first, I'm just multiplying 2. Okay. 2 plus 4 under root 6 upon 5 iota. Okay. Plus 5, which is equal to 0. Okay, now let's see what we're dealing with. So here's what I would recommend. I would recommend that you take this 25 outside the equals to sign, so it becomes 5 upon 25, which can be written as 1 upon 5. Okay, so 1 upon 5, and in the numerator, let's see what's going on. 1 plus 4 root 6 iota, and this becomes 4 into 6, which is 24. Iota square is minus 1, so that means minus 24. Okay, and here you can start opening up the bracket. Minus 2 upon 5, not just opening up the bracket, but also separating it. Minus 4 upon 5 root 6 iota plus 5 equal to 0. Okay, now 1 minus 24 is minus 23. So what this becomes is this. Let's write down the simplified version inside. Let's duplicate this to save some time. Okay, and 1 minus 24 can be written as minus 23. Okay, so minus 23 upon 5 plus 4 upon 5 root 6 iota minus 2 upon 5. Okay, minus 4 upon 5 root 6 iota plus 5 equals to 0. If you wanted to simplify minus 2 upon 5 plus 5, you could have done that also. But now use your calculator and do the following. Do minus 23 upon 5, minus 23 upon 5, minus 2 upon 5 plus 5. You'll notice that this, and this simplifies to 0. And we can already see that 4 upon 5 root 6 iota minus 4 upon 5 root 6 iota also simplifies to 0. So 0 plus 0 equals to 0. Therefore, shown. Okay, expect this to be around 3-4 marks. Therefore, or hence proved. Okay, or hence shown. Hence shown. Now, the next question is write down the other solution of the equation. Okay, how do I write down the other solution of the equation? Let's see. So the other solution of the equation can be solved, can be figured out by simply solving this quadratic equation using the middle term formula. Okay, and then you will learn that there is a standard rule to be applied here also. Okay, so we'll see what that standard rule is. But first, let's solve it the way that we do it. So x equals to minus b, that means minus minus 2 plus minus b squared minus 4ac, which means minus 2 squared minus 4 into 5 divided by 2a, which means divided by 2 times 5. So x equals to 2 into 2 is minus into minus is plus. So positive 2 plus minus square root of. So what do we have here? We have minus 2 squared, which is 4, and 4 minus, let's see, we have 4 minus 4 into 5 into 5. So that's minus 96 divided by 10. So if your calculator is in complex mode, okay, make sure that your calculator is in complex mode. And then if you take out the square root of minus 96, so you get 4 under root 6. That means x is equals to 2 upon 10 plus minus 4 under root 6 iota upon 10. Okay, so what do we get? We get 1 upon 5 plus minus 2 upon 5 root 6 iota. Now notice one root was already given to us. It was 1 upon 5 plus 2 root 6 iota. So that means the other root, okay, so the two roots that we get are this. 1 upon 5 plus 2 upon 5 root 6 iota. The other root that we get is 1 upon 5 minus 2 upon 5 root 6 iota. Okay, so the rule is, the question is that do we have to do it this way? If we were given one root already, we can see that the only difference in the other root is the sign of the imaginary part. Okay, and that's the standard rule. The standard rule is that if a plus b iota is one root, then the other possible root must be a minus b iota. Okay, so this is why, because you're always taking the square root of, you're always taking plus minus square root. Okay, so this is a standard rule that you must remember. Okay, so this is a standard rule to keep in mind. Okay, now one last concept and then we're done. And that is a lengthy one, and that's square root of complex numbers. Okay, how do we find out square root of complex numbers? Could we have done part A with factorization like part B? Okay, now whenever the question asks you to show, that's a good question. Whenever the question asks you to show, the way that you show it is by plugging it back into the equation. Okay, that's how you show. Every time the question asks you to show, the way that you do it is by plugging it back into the equation and showing that it simplifies to 0. Okay, and normally you'll notice that you don't really have to show that a certain complex number is a solution to a quadratic equation. Normally you will get cubic equations. Okay, and the only way to prove that is by plugging it back into the equation. All right, now let's find out square root of complex numbers. So let's say that you have the following. Let's say that you have 5 minus 12 iota. Okay, and you need to find out the square root of it. Okay, so we're straight away doing an example question. Now we know that once we do end up finding out the square root of it, it's going to end up with something like this, a plus b iota. Okay, so this is what the end result is going to be. So here also we're going to use the same method, which is comparison. Okay, we're going to use the comparison method. And how is that? Here's how. So let's duplicate this. So what we have to do to solve something like this is to get rid of the square root And the only way to do that is by taking the square on both sides. So once we take the square on both sides, this becomes 5 minus 12 iota. That's a no-brainer. The right-hand side becomes a square plus 2ab iota plus b iota square, or simply minus b square. Okay, I've skipped a step. Yeah, so I'll do it. Plus b iota whole square. So this becomes a square plus 2ab iota minus b square. Now rearrange it in such a way that you write the real components first and the imaginary after. So it's a square minus b square plus 2ab iota, which is equal to 5 minus 12 iota. Now a square minus b square is equal to what? Is equal to 5. That's one equation. Okay. Expect this to be around 4 or 5 marks easily. And the other equation that you will get is by comparing. So real with real, and now imaginary with imaginary. So that's minus 12 equals to 2ab. So 2ab is equals to minus 12, which means ab is equals to minus 6. Okay. Now what we're going to do is we're going to solve them simultaneously. So this is the second equation. And this is not a simple equation. Okay. It's not that you have two linear equations. These are two non-linear equations. So a is equals to minus 6 upon b. That is the third equation. And this is going to go in the first equation. We're going to plug it back into the first equation. So minus 6 upon b minus b square is equals to 5. So that means 36 upon b square minus b square is equals to 5. Now let's take the LCM, which is going to be b square. So we have 36 minus. Okay, so we'll end up with a disguised quadratic equation. Okay, keep that in mind. So we'll end up with 36 minus b power 4, which is equal to 5. That means this is what we end up with. We end up with 36 minus b power 4, which is equal to 5b squared. Let's get all the terms on the right-hand side. So we have b power 4 plus 5b squared minus 36 equals to 0. Now you can solve it as it is, or you can first turn it into a quadratic equation by doing substitution. Either way, this is what you end up with. You end up with b power 4 plus 9b squared minus 4b squared. So we're doing middle term breaking over here. Minus 36 equals to 0. Let's take b squared common. So you have b squared plus, you have b squared plus 9. Okay, and then this is, let's take minus 4 common. So you have b squared plus 9 equals to 0, which means b squared minus 4 into b squared plus 9 equals to 0. Now remember, just b itself has to be a real number because it's the coefficient of iota. So when you take b squared minus 4 equals to 0, this is something that you can solve. B squared equals to 4, b is equals to plus minus 2. But when you do b squared plus 9 equal to 0, this is not possible. So don't think that just because you now know complex numbers, you can solve this. Well, you can solve this, but it won't be a valid answer because we just want the coefficient of iota, which has to be a real number. Okay, combined with iota, it's an imaginary number, but just the coefficient is real. So we have the value of b. Now remember, a was equal to minus 6 upon b. So that means a is equal to, so when we take b as 2, a is equal to minus 6 upon 2, which is minus 3. And when we take b as minus 2, that's when we get a as positive, which is 3. So that means the square root, there are two possible square roots. Okay. One is 3 minus 2 iota, or the other is minus 3 plus 2 iota. Okay, so these are your possible answers. So when we took the square root, we got two possible answers. One is 3 minus 2 iota, the other is minus 3 plus 2 iota.